Hi everyone, good morning, and thank you for joining the session. My name is Andrey, I'm Research Associate at Imperial College London, and today I want to share our recent studies on intraday continuous markets. And specifically, we will focus on battery energy storage systems and real data that we got from Denmark DK1. So be ready for many complex and beautiful figures with a lot of price volatility. Just a few words about myself. As I said, I'm now working at Imperial College London with Professor Pierre Pinson. And before that, I was working as a researcher at the University of Manchester. And before coming to the UK, I did my PhD in Moscow, Russia. Over the last years, I have been developing different optimization models for power systems and electricity markets. For example, in Manchester, we developed some interesting models for aggregated flexibility analysis in distribution networks. And if you're interested in these topics, please feel free to contact me. And also, I'm developing my YouTube channel. So if you want, please feel free to join it and you may follow my recent studies. I also publish some general thoughts and things about academia. All right, let's talk about intraday markets. And first, I would like to start with some basics, because even analyzing and visualizing intraday markets is not easy. And as a motivation, on the right, I show you a picture of a medium-sized battery storage system. You can see only 2 containers here, so maybe the total energy of this project is about 2 megawatt hours, maybe a bit more. And I want to say this bold statement that battery storage doesn't produce electricity. So the only thing it does, it stores energy and shifts it. So imagine you invest in this project, which may cost well above 1 million euros. How will you operate this battery to ensure profitability? And this is quite a difficult question because, again, we cannot simply produce electricity. So what we can do, we can participate in different markets. This was already mentioned today. There are many possible revenue streams for storage. Sometimes this is called revenue stacking. There are day-ahead markets, some frequency services, congestion management, balancing markets, and so on. And the only thing I will talk about today, the focus of our studies, is intraday continuous markets. And to get profit in this market, we need to perform arbitrage. This means that we need to buy electricity when the price is cheap. We need to charge our battery. Then we wait till high prices, and then we discharge our battery. Now, within this topic, there are so many research problems that we don't even have time to discuss all of them. We need few hours. Researchers are applying different algorithms to analyze this problem. There are forecasting models, algorithmic trading, a lot of machine learning applications. I've seen papers where people use reinforcement learning to train trading agents. And today I want to focus on a very specific, interesting problem, which is called anomaly detection. So we will try to detect and analyze trading sessions with unusual, abnormal prices. And the goal, my goal for today's talk is simple. I will show you why detecting anomalies is important, and then I will share with you a very cool tool, very simple algorithm that you may want to use in all other data-driven studies. You may apply it to any data set. All right, so in this picture, I visualize how intraday market dynamics work. And the important thing is this right part. We can see 24 green hours. These are so-called delivery hours. So we are trading energy for 24 delivery hours for day N. And we are trading for these hours continuously. But an interesting thing, as you may see here, is that we start intraday markets on the previous day at 3 p.m. This means that the longest possible trading session is 31 hours and the shortest possible session is 8 hours. And it is important to understand that we have these 24 sessions partially overlapping. We can say that we are trading in parallel in multiple sessions. And within each session, we have sellers and buyers, and they are submitting order to sell or buy electricity. Following trading terminology, economics terminology, we call the price for selling ask price and the price of buying bid price. And you can see I show this by these two continuous curves, the blue and the red one, that we have continuous prices in each of these parallel 24 sessions. Continuous meaning that usually at each millisecond you have some orders in the order book, and there exists a price for buying and a price for selling. So to make sure we understand why we have prices and why prices change all the time in continuous markets, I prepared this simple example with just 3 timestamps, and at each time we have some orders and we arrange them by their value. So let's take a look at these red orders. These are bid orders for buying electricity, and the best bid order has the price of 60 euros. This is the maximum price people are ready to pay right now for buying energy. And the best ask price, the best price for selling energy, is 75 euros. So you can see now these two curves, and you may notice that there is a gap between the curves called bid-ask spread. This means that no trading is possible right now. The prices simply don't match. Then let's move to timestamp 2, maybe a few milliseconds later, maybe a few minutes later. Some market participants submit new best bid order with a higher price. Now it's 65 euros. And we see that there is a shift in the bid price and the price increased. But still there is a gap and no trading is happening because the prices for buying and selling do not match. And finally, at timestamp 3, we have new buy order, bid order, with a high price, 80 euros, and it overlaps with the best ask price. This means that we can buy these 3 megawatts for 75 euros. We eliminate this order, it disappears from the order book, and all prices shift up. So you may notice the book is updated and the bid price goes up as well as the ask price. So this is what is happening when we have more and more orders for purchasing energy. As in the stock market, the price goes up. If we have more orders arriving for selling energy, the price may go down. This is the basic visualization, and in this project we work with a real data set called Intraday Continuous Market for DK1 Denmark zone for 2023. And here is an example of just one trading session. In the whole year we have 8,760 trading sessions, and in every trading session this is happening. We can see the best bid price and the best ask price and how the trading is evolving. For example, in this case, we can see that at the beginning of the session there was low volatility, not too much trading happening, and then closer to the end of the session we have more and more trading, and I would say that in this particular session the prices accelerated and the prices for buying electricity grew up quite significantly, from 180 euros up to almost 270 euros. So this is just an example so you can feel how markets and particular sessions work. And one more key thing here is this black line. It is day ahead price. As speakers discussed today, it is also important to know what was the day ahead auction, and for these markets this serves as a baseline for trading, because all market participants, they see what was the day ahead price and they can use it as a reference point. Now, this was just one trading session for 1 hour, but how can we visualize the whole trading day, 24 trading sessions in parallel? And we are developing this visualization for our project and papers, where our goal is to show all parallel sessions together to demonstrate if the trading day was normal or abnormal, if there was some anomalies. So what you see here is the black line, 24 day ahead prices, and the red scatter plot corresponds to the latest intraday bid prices. So we can see how the markets concluded, what was the latest price for buying electricity. But what were the dynamics in these intraday markets? And if we visualize all intraday sessions, it will look something like this. So I think it's an awful visualization because all sessions overlap, all these intraday dynamics overlap, and it's quite difficult to see what happened in the trading. Therefore, what we came up with is to use colors strategically. For example, for the early hours, we can say that these will be green hours, then midday trading blue, then pink and red. And I think it becomes quite possible now to analyze what was happening in this particular day, how the prices evolved. You may notice that in the evening hours, the trading had some price peaks, and I would say that the trading ended on a high note with a significant price increase. And in this manner, we were visualizing some trading sessions that are of interest. Now, that was about the fundamentals and visualization. Now, I want to tell you about one tool that we are developing for intraday markets. And this is a tool for detecting anomalies, specifically event-driven anomalies. You may notice familiar faces on this slide. So this is how this research started. We just found a LinkedIn post about recent failures in the Scandinavian power systems, for example, in Sweden. So we know the exact date and time of some failures where a few gigawatts of power were lost. And then we can confirm that this indeed happened by checking frequency data from FinGrid. And we know that something wrong happened to, let's say, Swedish power system, Finland power system, which are interconnected to Denmark. This means that if market participants in Denmark see these events, this may impact the trading. And now, using our visualization tool, we can show this specific day. So with this vertical red dash line, I show the exact time of the failure. And that was a failure at the Forsmark Swedish power plant. I would argue that something happened to this intraday market in Denmark, because if you check the pink line, the evening trading sessions, they were trading as usual. But then a few hours later, after the failure, we see some disturbance, some significant increases in the prices. And then several hours later, the price dropped back again. So what was that? Maybe that was an event-driven anomaly. And power system failures are not the only anomalies that may impact trading in intraday markets. There are many more reasons why the price may be abnormal, for example, due to wind generation. In this complex, messy picture, you see the whole year of wind generation in Denmark, offshore generation and onshore. And I think you notice that this generation changes a lot. Sometimes we have almost 5-6 gigawatts, sometimes much less. And when analyzing such a data set, we can put a simple condition. Let's find 2 consecutive hours where the total wind generation changed a lot, let's say by 1 gigawatt. And as highlighted here in red, there were 4 events like this with a rapid change in wind generation. Then we can say, okay, but were there any events where wind generation changed by 500 megawatts within 1 hour? And maybe you'll be surprised there were 200 events like that. And then we can analyze such events and see if they caused any price anomalies or not. Here I zoom in into a specific week, and you can see that indeed at some day there was more than 1 gigawatt rapid shift in wind generation increase, and then several days later the same behavior but rapid drop in wind generation. And once we know the time of these events, we can analyze them one by one. And this is example of an event where we had a significant drop in the wind generation. And I would say that this is a very interesting session, especially for storage, because it may present a lot of trading opportunities. You can see how volatile was the trading, a lot of differences in the day-ahead prices and intraday prices. And moreover, if we take a look at the end of this trading session, many intraday prices, they were above the day-ahead prices, which creates this imbalance. And also look at the numbers. If we charge our battery somewhere in the morning, we can charge it almost for free, for €0. And then we discharge it in the evening for 110 euros. So very interesting, very opportunistic trading session for storage. And maybe this was caused by rapid shifts in our wind generation. But what I was showing you so far was just manual analysis. We found some LinkedIn posts, we found wind generation data, and we manually checked if prices were normal or abnormal. The question is, can we do this in a systematic manner? And we say in this project, yes, we can use the algorithm called isolation forest. So here I would like to ask you if anyone has heard about isolation forest. Yes? Yes? 2 people. Yesterday at the project meeting, no one heard, so 2 people is a progress. I want to show this algorithm because it's very simple, it's very powerful. It can be applied to any large high-dimensional data set, and you don't need to have any labeled data. So you just drop your data set into this algorithm, and it will show you some normal data points and anomalies. And I prepared a simple example to show you how the algorithm is working. So this is just a 2-dimensional data set with 150 points. And imagine our goal is to find anomalies. So I'm asking you, please show me the anomaly points. And as humans, we look at this picture and we see the center of the figure and we say, everything is in the center, it's probably normal. And anomalies should be somewhere further from the center. So maybe this top point or right point is an anomaly. So our intuition will be to compute some distances. But the isolation forest algorithm is working in another manner. It is not calculating any distances. Since it is called a forest, it has partitioning trees, and it simply randomly splits the data set. So imagine we randomly split this data set. Actually, funnily enough, the monitor is already split. So let's say we focus on the left part of this data set, and then we check, okay, we make this partitioning, which part is larger? And then we focus on the larger part, and we discard what was with the less points. And then we keep doing this, and after a few iterations, we will find that there still exists some subset of data which we haven't explored yet, haven't partitioned yet. So maybe this will be the normal points. And anything that was discarded, partitioned many times, we can say that this is closer to anomalies. This is the result of the algorithm when I implemented it in Python. And you can see that indeed everything in the center is blue, meaning normal points, and everything with a negative score, anomaly score, they are anomalies. And here is the visualization of how the algorithm is working. So this is just one run of the algorithm. We start splitting our space completely randomly, vertically or horizontally. And then you can see that we have less and less remaining points. And then we stop and we say that these points, they are blue because we haven't touched them yet. And there are 2 points in red. We isolated them a lot. That's why probably they are anomalies. Now, we implemented this algorithm for real data set. And this is a picture of one trading session, but you cannot just drop this picture for the algorithm. It will not understand what to look for. So you need to engineer some features. And in this case, we show to the algorithm what was the trading number of the session length, mean prices, standard deviation of the prices, etc. So you can see here 9 parameters. And then we run the algorithm for 8,700 sessions, and we see this. So this is the result of the anomaly detection. And there exists, I would say, a big cloud of normal sessions. And there actually is some linear dependency between bid and ask price. But then many sessions, they fly away and they become classified as anomalies. And why we're doing this? Well, let's see one of the extreme anomalous trading sessions. This was the session that we found using the algorithm. You may notice how volatile the prices were. Again, at the beginning of the trading day, the prices were close to 0 or 50 euros. And then there was a huge spike and we could have sold energy for almost 800 euros. So very interesting trading session for storage. We are not sure if this is event-driven or not. We checked the wind generation dataset. The dataset says that there was a low wind generation during that date, but we are not sure if this was event-driven or not. But anyway, we can find such very interesting opportunistic trading sessions for our storage. And this ugly picture shows the whole anomaly analysis for the year. So 365 days, and each day has 24 hours. So we can see where anomalies were happening. And if we zoom in, we can see something interesting, that trading sessions with anomalies sometimes happen in a sequence. For example, here in one day, there was evening, 4 or 5 anomalous trading sessions. and then the next day again something was wrong in the evening. So it is worth exploring this. My last slide with conclusions and questions. So why we are doing this? Why we are detecting anomalies? Because we believe that it will be useful for understanding the data set, the prices that we have, and this will further help us to develop and adapt our trading strategies. And moreover, I showed you how we ran the algorithm once, but it can be run in a loop continuously. So if you have new data today, we can add this data to the isolation forest and ask it if it is an anomaly today or not. And if it is an anomalous session, then we need to adjust our trading strategies. There are many other open questions that we are targeting in this research. We are developing also a reinforcement learning algorithm for trading. And overall, we are trying to understand if all these strategies will be a game changer for battery storage profitability. Because on paper, this all sounds very promising. We can increase our profits by 40–50%. But then in reality, all market participants will see the same data. They will find the same anomalies. They will train the same reinforcement learning agents, and maybe they will simply capture all existing opportunities. So this is a very interesting research question. Will AI change profits of battery or not? And one more thing, we are developing a GitHub repository called Intraday Power Analytics. I am putting some simple examples there and data sets, so please feel free to check it out if you're interested, and please contact me if you want to collaborate on this topic. Thank you very much.